Today I wanted to do a quick little video to explain the universal set as well as a little bit about subsets and the complement of a set. So let's get started. The universal set is generally symbolized by the letter U. So if you just think of the word universe, okay, the universal set is going to be the set of all of our potential elements under consideration for a specific situation. So for example, the Olympics just got over, so the set U could be all of the 2004 Winter Olympics athletes. That would be an example of a universal set. So in that set, since we've got all the 2014 Winter Olympic athletes, we would know that only those people would be considered, potential elements. So once we define a universal set, we are restricted to considering only elements from that set. It's our entire universe. So somebody that was not in the Olympics in 2014 but climbed Mount Everest would not be considered an element of the set or part of our universe. So now that we've talked about what the universe is, let's talk a bit about subsets. A set A is considered a subset of a given set B, and the A and B here are just arbitrary. I could have used Y and Z, I could use C and D. They're just ways to identify a set. So a set A is considered a subset of a given set B if and only if all elements of the subset A are also elements of the given set B. So in a brief summary, if A is going to be a subset of B, if set 1 is going to be a subset of set 2, every single element that you see in set 1 has to be included in set 2. Or every element you see in set A has to also be an element you see in set B, if A is a subset of B. And it didn't copy over the way I'd hoped, but I'm trying to get my pen to work here. A subset would look like a sideways U. Sorry about this. It would look like a sideways U with a line underneath it. That's how we denote a subset. So here's my example, and I took these names from the 4-man bobsled team in the 2014 Winter Olympics. That's my theme for today if you haven't noticed already. So if set A consisted of 2 members of this bobsled team, Holcomb and Langton, and set B consisted of Holcomb, I'm going to just butcher these names, Thomas Vitz, Langton, or Fote, then we would say that A is indeed a subset of set B because every member in A is also a member of B. Now I can't say the reverse. I cannot say that B is a subset of A because every member that I see in B is not included in A. So I would say that B is not a subset of A in this example. And up here I had drawn one. Sorry about that, not pasting over. So in this example, if A were, Stephen Holcomb and Michael Phelps, and then B were Holcomb, Thomas Vitz, Langton, Fote, and if I butchered those names, I am so sorry. We in this case would say that A is not a subset of B because Michael Phelps is not part of set B. For A to be a subset of set B, every element in A would also have to be found in B. And now we're going to talk a little bit about the complement of a set. So again, our universe in this example is going to be all of the 2014 Winter Olympics athletes. So what is the complement? Well, our universe obviously is all these athletes, okay? The complement of a set A consists of the elements of our universal set which are not found in set A. So complement of A is written like this, A with a little tick above it to the right. So basically A and the complement of A cannot have any matching members. In my example, if A were to be the 4 members of this men's, 4-man bobsled team, then A prime, or the complement of set A, would be every single athlete in the 2014 Winter Olympics besides these 4 guys. So I hope that that kind of made sense. That if you were to draw, sorry about this, I'm trying to get used to this new writing tool I've got. So if our universe was this rectangle right here, and this was the 2014 Winter Olympic athletes, all of them, okay, then if set A was the 4-man bobsled team, then A prime would be everything else. So set A would be this little circle right here, and it would be our 4 members that we'd mentioned. Then A prime is all this other stuff that's not part of the circle. So I hope that that helps you a little bit with the complement with the universal set and with subsets this week. Let me know if you have any questions.